TTL Computer 2. Today we'll be taking a look at our memory card in the simulator, and we'll be looking at the issue that I identified as part of my review of the memory card in preparation for doing my serial I/O card. So just a quick review. So here we're in our memory card. We have our address lines coming here on these buffers. We have our control signals here, not read, write, and U clock, and we have our data bus driver and buffer here. And then we have our ROM and we have our RAM, and we have this chip down here that's uh, generating the output enable signal for our data bus. And this is an active low signal. And that's kind of where we're going to be looking at this issue. All right, I'm going to make this a little bit larger so you can see this a little bit better. And then we're going to start our simulation. Okay, so I'm going to go here and start our simulation, and we'll take a look quickly at the current operation and the issue. All right, so we have our ROM is mapped in at address, hex 0, and we have our RAM that's at address 8000. And so right now we have 0. 0 is on our address bus, and all of our control signals are in their inactive state. And we can see here that our output enable is also high, which means that our data bus is inactive or in a high Z state. All right, so let's go and we're going to do our enable our read, and we can see down here that the output enable went low, and that enabled our data bus as we would want it to be, right, when we're doing a read operation. Now I'm going to do a write operation, and we're going to see that the output enable line is still high. So our data bus is still inactive. And I'm going to now do the U clock, which would be the actual write phase. And we see now that our output enable went low, which means that our data bus is being driven by the buffer. And again, at the U clock phase, right, the write signal is being raised, the U clock signal is being raised, and that clocks in our whatever's on the data bus into our RAM chip. And that's the issue right there. So right now, the data bus signal is high, which means it's not enabled, and the signals are disabled. And as soon as we do the clock, the U clock, now the data bus is active, but at the very same instant, we're trying to clock that. Trying to clock in what's on the data bus into our RAM. And that's the issue. That's a race condition, right? Those things are both happening at exactly the same time. And the output from our data bus driver chip might not be stabilized yet before it's being clocked into the RAM chip. And that's a race condition, and that's the problem. And this again is, I think, is another issue of the simulator not being able to really to detect this issue. The simulator is probably fine with this and would never detect a problem, but our hardware, right? The simulator is running in a linear fashion. It's doing, A, B, C, D, E, F, whatever it needs to do to process the circuit. But our hardware is running in parallel. A lot of things are happening at the same time. So that's the issue, is that we really want, just like here, as soon as the read signal uh, it goes low, the data bus goes active. We really want that same behavior. When the write signal is raised, we really wanted the data bus to go active, but it's not. It's waiting for the U clock. So that's the error. So what's our remedy? Our remedy is going to be this, right? Here's our read-write signal coming in, and we want to get rid of that. And we want to just have that be wired to ground, and that's our fix. And let's take a look at the behavior now that we get with that. Okay, we'll start our simulation again. All right, so now we see that all right, so now the read signal is high, but take a look here. the output enable signal is low. So our data bus is already being driven, even though the read signal is not low yet. And why is that? That's because the address line, the address uh, is in the address range of the ROM or the RAM. And as long as the address now is in the space of the ROM or the RAM, this signal is going to be low and our data bus is going to be driven. Let's say go to hex address 2000, and now we see our output enable signal is high because that address 2000 is not in the address space of the ROM or the RAM. So now we're going to be driving the data bus uh, a little bit sooner than we would have before, but it's going to be active anytime we're in the memory address range of the RAM or the ROM. So now let's take a look at the write signal. So the write signal now is going to go high, but again, we're already have this signal is being active low because the address is in the range of our ROM and our RAM. Again, if it's not in the range of our ROM and RAM, right? 2000 hex 2000, the output enable is high, and our data bus driver is in a high Z state again. So that is effectively our fix. So the write signal is being raised. The data bus signals are already going to be stabilized, and right, our U clock signal is going to occur here, and our RAM chip is going to clock in the stabilized signals from our data bus. So that's going to be our fix, and it's not quite as eloquent, I think, as what I was attempting to do before, but in a nutshell, I was using the wrong signal. I was using the same signal that the RAM chip write signal is using. I shouldn't have been using that. I should have just been using the simple write signal there is what should have been used. Okay, so that's our fix. We want to remove the read-write signal that was there before. We want to cut that signal and just wire that to ground. So let's take a look at what I decided to do. Okay, so this is the fix I decided to do. So I basically had two choices. I could I could have scratched out the trace that was there and rewired this pin, which is was the read write signal pin. I could have rewired that on the underside of the board to ground and scratched out that trace. Now, I always try to prove out my changes before I do them. So I had some extra board and I tried to scratch out the trace, and I really wasn't happy with how that was working out. I wasn't really comfortable doing that, and it wasn't great also on the underside of the board to wire this pin to ground on the underside of the board. I wasn't really pleased with that. So I thought that the better way, right, those are destructive changes doing that, scratching the board. My preference was to go with an undestructive change that for some reason, if I wanted to, undo this change, I still could. So what I did was similar to the backplane board fix I did, I bent out this pin for the ore chip and I wire wrapped that pin and put some heat shrink tubing on there and just grounded that wire here to this bypass cap that we have here because we had a good ground point right here. So that's the way I chose to do that fix. And again, if I did want to undo this for some reason, I always could. I could unwire wrap that pin and bend the pin back down and reinsert the chip and snip that wire. So I felt that was a better way to go, and I was more comfortable doing that than the other. So that's the repair in the card. And this now is the card, is our memory card back in the back plane, rerunning our regression tests to make sure that the repair is functional and that we are passing all our regression tests, and we did. And I also, if you notice here, that this is actually the memory card slot in our back plane. I tested it there first, but if you remember, I had recently completed the back plane build out and soldered in the expansion slots. Now, since the memory card, again, is kind of our pattern for all the expansion cards, I can take the memory card. The memory card can run in any of the expansion slots. So that's what I did. I popped the memory card into our first expansion slot as a test to verify again that the memory card passed regression tests in the expansion slot, and that also verified that the expansion slot was wired correctly. So, okay, so that's it. That's our issue, and that's the fix. The fix was not too big of a deal, and I'm glad to say that's all done and repaired, and we are back on track again. And I will shift my attention back now to our serial card uh, design, as well as continuing my work on the enclosure build out. But that's it for today. Until next time. Thanks for watching.